the data types, how to declare the variables. Yeah, I just been listed you all the data types that are available, and also I just been explained you how to declare the variables in the code. So these are the things what we just been learned in our previous session about the data types and all the things. Okay. Now today we'll talk about this one here. What we are going to discuss today is we've just been talking about a concept like data types are actually divided into two different categorizations. Data types are actually divided into two different categorizations. We divide them into two different categorizations. What are two different categorizations? We call them as value types and reference types. We call them as value types and reference types. So what are these value types and what are these reference types? Okay, so let me clarify you today what are value types and what are reference types. Say, in a program, I'm just going to declare something, int I is equals to 100. So now guys, some memory is allocated for this I now. How much memory? Louder here. How many bytes? 4 bytes. Yesterday we explained, you know, the sizes of everything, 4 bytes. The memory that is allocated is 4 bytes. It's going to allocate 4 bytes of memory for this. Okay. So it's going to allocate 4 bytes of memory for this. Where this memory is allocated? 4 bytes memory allocated, but where that 4 bytes of memory allocated? We learned in the C language, recollect yourself, where exactly the values are stored. Stack here, stack. So the values are going to be stored on a stack, a particular memory location called as a stack. So basically 4 bytes of memory will be allocated for this. How much? 4 bytes of memory will be allocated for this. And these particular values are going to be stored for you on the stack. Where they are stored? On the stack they are going to be stored. Are you clearer or not? So they are going to be stored on the stack memory. Okay. So if you just notice this one, what is stack? Stack is basically a data structure. Stack is actually a data structure under which the values are going to be stored. So a stack will be present like this. One end of this will be open and one end is closed. So we call this as a stack. So look guys, we call this as a stack. One end of the stack is open, one end of the stack is closed. Now, whenever you're trying to declare your fields or anything in the code, memory will be allocated for that and all the values will come now and sit inside of this particular stack. So right now when I declared int I, how much memory? 4 bytes of memory is allocated and the value, the 4 bytes of memory is allocated on the stack and the value comes and sits on the stack now. Where does it sit on the stack? It will sit for you on the top of the stack. Where it sits to? Top of the stack. What is that? Right now guys, this is the top of the stack. So it is going to allocate 4 bytes of memory and the value will be stored inside of the stack. Where is it? Top of the stack. Now I am declaring one more variable, stage is equals to A. How much memory? 2 bytes. Character is 2 bytes. So now the 2 bytes of memory will be allocated for you on the top of the stack. Where is it? Now see guys, now all of you carefully observe. So the memory allocation is done for you on the top of the stack. This is the top of the stack. Every value will come now and sit on the top of the stack only. Every value that comes here will be sitting on the top of the stack only. Everything. You declare something, they will come now sit on the top of the stack. Now I'm declaring double D is equals to 34.56. How much memory? 8 bytes. The 8 bytes of memory will be allocated for you again on the top of your stack again. Okay, so my 8 bytes of memory storing the D value 34.56 is the value what I have. Stored for you on the top of the stack again. Is my point clear, all of you? Yes or not? So this is how the values will come now and sit for you inside of this vector stack like this. Like this, every value comes now and sits in the stack. Okay. So what is this stack? Stack is a data structure under which the values are going to be stored. Stack is a data structure under which the values are going to be stored. And second important point, the stack works on a principle. What is the principle? You know, first in, last out, or last in, first out. What is the meaning? If you come first into the stack, you will exit last. If you come first into the stack, you will exit last. If you come last into the stack, you will exit first. Okay. Suppose say, you just understand, you're sitting in a classroom now. The classroom has only one entrance. Entry, exit from the same direction. Correct? Entry, exit from the same direction. Okay. Think like this is a cinema theater now. This is a cinema theater, not a classroom. This is a cinema theater, one entrance. Okay. Now you entered into the theater. Where do you sit, guys? You try to sit in the last. In a cinema theater, you never try to sit in the first. You always try to sit in the last. There is a numbering system. Okay. There's no numbering system. You always try to go and sit in the last now. Okay, last row, next row, like this, one by one row will be filled. If you come last, you'll be sitting first. When the movie is completed, who goes out first? The people who are sitting in the first. But don't forget that when the people who are sitting in the first or the people who came last into the auditorium now. Right? At the stack, cinema theater is an example now. For a first in, last, or you are first, but you can go only last because you are in the back. You go only last. Or otherwise you can call it as last in, first out also. Anything, a first in, last out, or a last in, first out, whatever it is. That's what we just call a LIFO or a FILO. Last in, first out, or first in, last out. Is it clear, all of you? Yes or not? So like this, the values will be stored for you within the stack memory. Like this, the values are going to be stored within the stack memory like this. Every value comes now and sits into the stack. Okay now, and next third point. What the first point I said here? Values are stored in the stack. When you declare anything, the values are stored in the stack. Point number 2, stack is a data structure and this works on a principle. First in, last out, or last in, first out. Okay now, and another important thing about this stack is under the control of operating system. Stack is under the control of operating system. Means whenever a program execution starts, operating system will create a stack and gives to the program for storing its values. Whenever the execution of a program starts, operating system will create a stack and gives it to the program for storing its values. And remember, no two programs can share the same stack. Everyone has their own stack. It is something like you go to a big shopping mall. You go to a big shopping grocery market, a big grocery market. So in the grocery, to take you carry a basket. Yes or not? And the basket is specific to you only. Will you carry the basket for other people? Everyone will have their own basket now. You will carry your own basket, put all your belongings there. So stack is also same. Every program will have its own stack. No two programs can share the same stack. Not possible. Clear, all of you? Every program must have its own stack. That is, no two programs can share the same stack at all. Not possible. Okay, this is the third important point. 4. Stack can allocate the memory only in fixed length. Stack can allocate the memory only in fixed length. What do you mean? At the time of allocation, you can ask the stack, you want 1 byte, 2 byte, 4 byte, 16 bytes, 32 bytes. How much you ask it, will allocate you. But once after the allocation is completed, okay, that cannot be increased or decreased again. Once after the allocation is completed, that cannot be increased or decreased again. That's not possible. For example, all of you, what's it is? you went for some matching store, or otherwise you just went for somewhere. You want to purchase some cloth. You want to purchase some cloth now. Okay. So you just asked him, give me 2 meters of the cloth. Give me 2 meters of the cloth. He has cut it. After cutting it, you called up your tailor and asked it. The tailor said, no, 2 meters won't be sufficient. Get me 2.5 meters. Can you ask him to exchange it? Tell me. Once cut, no, you're required to again pay bill for 2.5 meters again. But they will not take this back and give you 2.5 meters. Are you clear? So it was cut. You should tell him clearly. Otherwise, you will take in 2 meters, but your tailor said 1.5 meter is enough. So can you ask him take this half meter back? No. That's what you're required to decide first only. So exactly, stack is also like that only. At the time of allocation, you can ask him how much memory you wanted. 2 bytes, 4 bytes, 16 bytes, it will allocate you. But once after the allocation is completed, that cannot be modified again. Are you clear? Stack can allocate the memory only in fixed length. That cannot be increased or that cannot be decreased also. Okay? Now come here. How much memory is allocated for integer? 4 bytes. Character? 2 bytes. Double? 8 bytes. All the sizes what we learned already. Data type sizes I already explained you. Int is 4 byte. Character is 2 byte. Double is 8 bytes. Clear now? Okay. Now guys, tell me, in the future, the memory is allocated now. In the future, can I just say I is equals to I plus 1000? I'm writing I is equals to I plus 1000. What is the I value? 1100. I value is 1100. Now tell me, can I store the 1100 under the same 4 byte memory location or should I increase? Same. Why? Because already we learned yesterday for 4 byte memory, the maximum acceptable value is minus 2 power 31 minus 1. For a 4 byte memory, what is the maximum possible value that can be stored? Minus 2 power 31 minus 1. Sorry, 2 power 31 minus 1. So starting from minus 2 power 31 to 2 power 31 minus 1. 1100 is within the range only now. Sir, if I go out of the range, you will get an error, overflow error, but it won't accept. What it accepts is only 4 bytes. What it allocates is only 4 bytes. The max possible value what you can store is 2 power 31 minus 1. That's all. Beyond that, you can't store, it won't accept. Okay? Don't think like it will increase the memory. Already said you, it can allocate the memory only in fixed length. No increases and no decreases will be possible. Within the 4 bytes, whatever you do it. No problem at all. Is it clear? Okay. Now guys, now look at this. I'm going to declare a string. String str is equals to, I'm just going to store a value, hello. How many characters? 5. Last class I explained, string size varies based on the value. 5 characters means 5 bytes. 5 characters means 5 bytes now. Okay. Now, assume like it is going to allocate 5 bytes of memory on the top now. It's going to allocate the 5 bytes of memory on the top and stores you the value. What value? Str is equals to hello. Storing the value over there. 5 bytes of memory allocated and storing the value over there. Is it clear? Now you stored the value. How much? 5 bytes of memory allocated for you. Now guys, later what you're doing is str is equals to str plus world. You're concatenating now. So what is the value of str now? Hello world. Can you store this hello world in the existing 5 bytes memory? Is it possible? So compulsory you require increase in the size or not? But what we learned already is stack cannot increase the memory. Once allocated, that is final. Cannot be increasing the size again. Are you getting my point or not? So now tell me, if the memory cannot be increased, can I manipulate a string? And when the memory cannot be increased, can we manipulate the string? You cannot. You can do the manipulation only within the 5 characters only. Are you getting my point or not? See, 100 became 1100, but hello cannot become hello. Hello, you want to modify within the 5 characters only, it can be modified. You cannot modify beyond the size. Then there is a drawback now. If I cannot modify the string, there is a drawback now. Are you getting my point or not? For this particular reason, strings are not stored on the stack. Strings are not stored on the stack. It doesn't store the string on the stack. It doesn't store this on the stack. Reason is, if you store in the stack, in the future, you cannot make any manipulations for this. So then where they are stored, sir? They are going to be stored in a different location. Recollect yourself. We learned about that also in the C language. Apart from stack, there is one more place where values can be stored by a computer. What is that? Heap memory. Perfect. What do you call that? Heap memory. There is one more location called as heap memory, and the values exactly will be stored for you inside of that particular heap memory only. So what is heap? So heap. This is a different thing called heap memory. And about this heap memory, guys, heap memory doesn't have any restrictions like first in, last out, or last in, first out. Heap memory doesn't have any restrictions like first in, last out, or last in, first out. What is that? Stack memory is like a classroom. Once you enter into the classroom, you cannot go out of the class until the class is completed. Am I right? Yes or not? You sit in the classroom, you cannot go out of the classroom until the class is completed. Are you clear? Okay. So the second thing is, so stack is also same only. You enter inside, you cannot exit out of the stack until the end of the program execution. Oh, so should I sit until the end of the program? Yes. I came inside now. I cannot go out until the program execution completed. I doesn't have any work to do. Even though I doesn't have any work to do, I cannot go out of the program until the execution of the program is completed. Is it clear? Yes or not? But a heap is like a cinema theater. What's it? You feel boring in the theater, you can go out of the theater. Yes or not? You can go out, you can come in, you can do whatever you want. So heap is also same. It's very flexible. You can resize the memory, you can deallocate the memory. All these things are possible with you in case of which memory? Heap memory, but not possible with stack memory. Not possible with stack memory. So what happens in this case, when you declare a string, what is going to happen, watch it all of you. When the strings are declared, it's not going to store the string value here actually. What it stores, it will store you the address. So notice all of you, it will store the address actually. What address? The address pointing to the actual value which is stored inside of the heap memory. The address pointing to the actual value that is stored in the heap memory. The value will be actually stored in the heap memory, and you will be having an address pointing to that particular location. So if you notice it, here is your value. Just a minute. For example, this is your value. It is stored on the heap memory. Address of it will be coming and sitting on the stack memory. Understood my point here? Okay. So now, actually, what is our discussion? Our discussion is that data types are divided into two categories. We call them as value types and reference types. That's what I said to you already. Now, let me tell you what is a value type and what is a reference type. Very simple, guys. If the value of a type is stored on the stack, we call it as a value type. And the address of a type is stored on the stack, we call it as a reference type. Did you understand? What is that? If the value of a type is stored on the stack, we call it as a value type. And if the address of a type is stored on the stack, we call it as a reference type. Point clear, all of you? If values are stored, value types. If addresses are stored, reference types. Can you tell me, now we listed 17 data types now. Can anyone answer this question? What comes under value types and what comes under reference types now? Louder. String and object. String and object are reference types. Remaining all are value types. Another way, not like that. Not string and object. Don't. All fixed length types are value types. All variable length types are reference types. I already classified you yesterday and day before yesterday. String and object are reference types. Remaining all are value types. Why? String and object are variable length types. All variable length types are reference types. But remaining 15 data types have size now. Mention you the size for every type for you. All fixed length types are value types stored on stack. All variable length types are reference types stored on heap. Is it clearer or not? Understood my point here? So that is the difference what we have, value types and reference types. Can I manipulate the string value in the future? Yes, you can. You can manipulate the string value in the future. You can do whatever you want on the heap memory. That's what I said here. Heap is like a cinema theater. Suppose the string, the job of the string is completed in the program, you can deallocate the memory of that string on the heap. But the job of the character is completed in the program, I cannot deallocate the memory. Why? Stack is created when the program execution starts and destroyed only in the end of a program's execution. Are you clearer or not? See, you go to in old, not like malls, guys. If you go to old cinema theaters, if you go to old and cinema theaters, they're not malls. Today we have concept of malls. Earlier, you go to old and cinema theater, and there you've taken your car and you parked your car, and you understand you cannot bring out that car until the movie is completed now. Are you getting my point? At least bike means you can bring it from some side or lift it or use it, but you cannot bring the car until the movie is completed now. Because so many cars will be parked around. So all the cars should be removed until the movie completed. Can you take your car out? You cannot. Are you getting my point here? So stack is also the same. If you enter there means you can't exit. But see, this heap is like a shopping mall. Today see multiplex theaters are there. In a multiplex theaters, you see how the parking are arranged. Anytime you can come, anytime you can go. In the middle of the movie, can I go and take my car and go out? Possible. But that's not possible in the olden variety of the theaters, where you will not have more space there. All cars are parked one before the other. So if your car is back, you need to wait until everyone removes their car. But that's not the case in the modern cinema theaters, what we have in the malls and all. Parking is very carefully arranged. Anyone can enter anytime, anyone can exit anytime. So I hope you got the point. What is here? He gives you the flexibility. What's it? Dynamic memory management. Dynamic memory management. Allocation, deallocation, anything can be done in the middle of a program, but that's not possible in the case of the stack. That is why every program will have a separate stack, but every program will not have a separate heap. All will share the same heap only. Every program will have a separate stack. No two programs can share the same stack. Why? Stack is specific to the program. Once created, will destroy in the end. But when you come to the heap, heap is not specific to all programs. Not specific to each program. Heap is common to all. If 10 programs are in execution, all the 10 can share the same heap memory. What is the meaning of it? What is the meaning? Just I explained you all the cinema there. Now tell me, in a normal theater, until a show is completed, can you go inside? Open the mouth, yeah. Until a show is completed, can you go inside and park your car? You need to wait until the movie is completed, all the cars are out, then only you can go inside. Correct? But in a multiplex, my movie is at 10 o'clock, I can go at 6 o'clock only. No one will stop me there. Are you getting my point? So that's what. So the same thing only I'm telling you. So here, heap memory can be shared by all programs, but stack memory cannot be shared by all the program. Every program will have its own stack. So which one is more futuristic, stack or heap? Heap. Heap is more futuristic. Are you clear? So we have a doubt. Sorry, heap is more futuristic. Why stack again? Stack doesn't have features. Yes or not? But stack is the primary memory of your program. Without a stack, heap doesn't survive. Yeah. End of the day, even though you store values in the heap, do you notice that address is coming on stack only? No stack, there is no heap. So what is the primary memory of your program is not heap memory. The primary memory of the program is always stack memory. So when the execution starts, stack is created first. Afterwards, you will start storing the values into heap memory. So the primary memory of your program is always a stack memory. Don't forget this. Are you clear? Under whose control stack memory will be there? Operating system. What about heap memory? Under whose control heap memory will be there? Listen, in our older programming languages like C language and C++ language, heap is under developer control. Heap is under developer control. Yes, guys, you learned about these functions now, malloc, calloc. When you call these functions, memory is not allocated on stack. Memory is allocated on heap only. When you call a malloc function, it allocates the memory where? Heap, not on stack. Stack memory allocation is completely operating system will take care. But heap memory allocation will be under programmer's control. Okay, but when you come to modern programming languages like Java, .NET, Python, in these languages, heap is not under the programmer's control, guys. Heap is under the control of one special component called as garbage collector. It is under the control of a special program called as garbage collector. We will learn about this garbage collector in object-oriented programming. Don't worry about it. So that garbage collector will be taking care of allocation and deallocation of the memory on the heap memory. Understood me? In older languages, it is under our control, developer. But in modern languages, it is under garbage collector's control. Point clear, all of you? Okay, that's why in the modern programming languages, this is called as, this is not just called as heap. This is called as managed heap. From now onwards, let's not call it a heap memory. What should I call? Managed heap. Because this is managed by a garbage collector for you. This is managed by the garbage collector. So we call this as managed heap memory from now onwards. So this is all about the stack and heap memory. Value types, reference types. Is everything clear? Understood or not? What comes under value types? Fixed length types. All fixed length types are value type. What comes under reference types? Variable length types. Don't pinpoint this is reference type, this is reference type. Simply say all variable types are reference types. All fixed length types are value types. So can you give me examples, miss? Yeah. Integer types, decimal types, boolean, date time, GUID, character are value types. String and object, reference types. Value types are will store values on the stack. Reference types will store address on the stack. Or values on the heap. What you should say? Value types will store values on the stack. Reference types will store address on the stack. Address means reference. Yeah. The other name for address is reference. It is going to store the reference on the stack. When it stores a reference of the stack, we call it as a reference type. When it stores the values on the stack, we call it as a value type. That is the classification between the value types and reference types. See guys, till I'm explaining about the data types only. I started with data types deep for yesterday, Friday. So Friday I started. You yesterday also is talking about data types. Now also I'm explaining only about the data types only. Are you clear? Okay. So fine. Heap can contain fixed values too. You can push the fixed types to heap. We call that as boxing. We'll talk about it later. Heap area, Java stack area, like that only. Anywhere that heap and stack are same here. In any programming language, that heap and stack are same only. Space. Yeah, guys. Read this. Data types are divided into two categories. First one, value types, and second one, reference types. Okay, value types. All fixed length types comes under the category of value types. Example, integer, decimal type, boolean, all these are value types only. Next, value types will store their values on stack. And stack is a data structure that works on a principle. You can call first in last out or last in first out. Next, each and every program when it starts the execution, a stack will be created and given to the program for storing its values. And at the end of the program's execution, stack is destroyed. Are you clear? Stack is created and given, end of the program, the stack is destroyed. Okay. So every program will have its own stack for storing values here. No two programs can share the same stack. Why, sir? Why they cannot store? Because the problem with the stack is, listen all of you, I cannot clear I until CH is cleared. I cannot clear CH until D is cleared. I cannot clear D until STR is cleared. So what is the problem, you know? If two programs are sharing the same stack, what happens, you know? Program 1 started the execution, started storing all the values in the top of the stack now. The program 2 started. The values are coming and sitting on the top of the stack now. Program 1 execution completed, but cannot destroy the memory of its members now, because it has to wait until program 2 is also completed. Before program 2 is completed, program 3 starts and the values will come and sit on the stack. You can never clear the stack at any point of time here. Are you getting my point or not? You can never clear the stack at any point of time. That is the reason why what it tells is every program take your own stack. Every program take your own stack. And this is specific to you. When the execution started, the stack will be created. End of the execution, destroy the stack. Is it clear? But app doesn't have that particular restriction. What is D, sir? Array, D is a double, guys. I declared double D. Listen, you're asking about this one. I declared a variable double D. Int I char ch double D. That is D. Okay. Next. Yeah. This is the next point. Stack is under the control of, and memory allocation is performed only in the once allocated, that is final, which cannot be increased or decreased. Already clarified here. Once the allocation is done, that is final, and you cannot ask it for increasing or decreasing. First only tell how much you want. It will allocate and give you. But afterwards, again, changing it will never be possible. Next one. Reference types. I read it. All variable and types comes under the category of reference types, and these types will store their values on heap memory, and their address or reference is stored on stack. Example, string and object. Heap memory doesn't have any limitations like stack, and it provides a beautiful feature. What is that? Dynamic memory management. And because of this, all programs in execution can share the same heap. Next. In older programming languages like C and C++, memory management is under, heap memory is under developer's control. Whereas in modern programming languages like Java and .NET, heap memory is under the control of a special component known as garbage collector. So we call heap memory in these languages as managed heap memory. Clearer, huh? And you see here is a same picture I shown you. I declared one integer, one character, one integer, one character, one double, and one string. And this is how the value memory is allocated. Okay? Fine. Next. Guys, one more important thing. Yesterday, I very clearly said you all of you one point, remember? Variables doesn't have a default value. Must be initialized at the time of declaration or consumption. I practically shown you also. Field has a default value? I'm talking with you only here. Field has a default value? But variables doesn't have a default value. Variables must be initialized at the time of declaration. At the time of declaration, they must be initialized. Guys, I'm going to declare a variable like this. string S. I did not initialize. I get an error. I get an error. But I don't know the value, guys. But you're asking me to initialize, but I don't know the value. When you don't know the value to initialize, you can say is equals to null. It's unknown value. I don't know. Are you clearer or not? I can do this. I can say null and I can say unknown value. I don't know this. Same way, I'm declaring object obj. I don't know value. I can say is equals to null. Now I want to declare int I, but I don't know the value. I don't know the value. So what I'm telling is equals to null. Guys, this is valid. This is valid. This is invalid. This is invalid. Same way I'm declaring one double. Double D is equals to null. Why, sir? Because null can be assigned only to reference types. Null can be assigned only to reference types. You cannot assign null to value types. You cannot assign null to value types. So when I don't know the value for a reference type, I can tell unknown and assign null. But when I don't know the value for a value type, I cannot assign null and I cannot say unknown. Not possible. This is the problem we have in all programming languages since many years. This is a problem what we have in all programming languages since many years. C language, C++ language, Java language, and initial versions of the C# also, we have this problem. To overcome this problem, in C# 2.0, they introduced a concept called as, what is that? Nullable value types. In which version? C# 2.0. So from now onwards, from C# 2, you can do this. Int I is equals to null. I want to assign it. I can assign it. I can do it. But to do that, you're required to suffix the type name with a question mark here. So this is a valid statement. Same way, double question mark D is equals to null. This is valid. So from which version I can do? From C# 2.0. But the declaration should have a question mark. So when you see the question mark there, what is the meaning of it? This is a nullable. This is nullable. What about this? Reference types are by default nullable. Yeah, for reference types, no need to talk about it. Reference types are by default nullable. Problem is only for value types. That's why the feature was added in 2.0, telling you nullable value types. Okay? See guys, understand the concept, that's all. Don't think where to use it, sir. I will show you all these things going forward in your classes. Okay? Today only I cannot tell you where to use it. You don't know anything about programming. What should I explain you where to use it? Understand the concept. Don't think beyond. Clearer? For everything, I will show you a practical implementation. I'll explain you case studies for you. And in the case studies, I'll give you an explanation. If this is the problem, how to resolve the problem. This is how we can resolve the problem. I'll tell you all the things. Okay? Just only stick to what I was telling. Don't think beyond that. Clearer? Okay? So going forward, we will learn about all the things in the coming classes. So this is a feature that was added in C# 2.0, what we called as nullable value types. Read it. Read it. The question mark is important. If you put the question mark only, compiler accepts a null value. That's the instruction to the compiler. Yeah. Watch it, accept a null value. If you don't put question mark, again the compiler will say, no, value types cannot accept null value. So now we have two different types of value types understood. One is non-nullable value types and one is nullable value types. Non-nullable value types will not accept null value. Nullable value types will accept null value. So new types did not come. For old types only, question mark prefix came. You put the question mark, that will become a nullable value type. Okay? Vivek, that only I said you, again you are asking the same question. That only I explained you very clearly. Array, don't think beyond where to use, I'll tell you later. Understand the concept, that's all. Again, you're asking where to use in real time. I cannot tell you, sir. You started eating food here and you're asking me, sir, what is the taste of biryani? Wait here, you will learn. Just understand the concept slowly. One by one, I'll tell you where to use and how to use it. Okay? Yeah. Next thing, guys, int I is equals to 100. I is which type? Integer. The question itself is foolish now. Why the question itself is foolish? You are saying int I, and again asking I is which type? Integer, no, very clear there. No confusion at all. The question itself is foolish now. Correct or not? Okay. Now see, guys. From C sharp 3.0. From C sharp 3.0. Okay, listen. From C sharp 3.0, we are added with a feature. What is feature, you know? From now, you can declare your variables. You can declare your variables by using var keyword. You can declare your variables by using var keyword. Now the question makes sense. I is which type? Well, I did not say int I now. I said var I. Now the question makes sense. I is which type? Can you answer? I is which type? I is integer type. How, sir? Now the type identification is done based on the value you assign to it. Array 100 is integer na. You assign integer, I is automatically integer now. Did you catch my point? Var f is equals to 3.14. Come on. F is which type? Louder. Wrong answer. Double, yeah. Yesterday only I said you. Decimal values are by default treated as a double. Yesterday I said you na? It's a double now, not a float. Now decimal. Now it is decimal. Now float. Now it is float. Okay. Next. Var B is equals to true. Base, wrong answer. String here, look at the value. Oh, you are looking F and P and answering. That's what I'm telling you. Look at the value. The value is in double quotes. Wait, that is not a string now. That is a string. That is string now. That's what I'm telling you. Focus on the value. Don't focus on the names of the variables. Now it is Boolean. Now it is Boolean. It is a string. Okay. Tell me now. You can't do this. Why? Type identification is performed based on value only. And you are not assigning a value. When you don't assign a value, I cannot recognize the type. So this is invalid. Are you clearer or not? Okay. So we call this as implicitly typed variables. Introduced in the version C sharp 3.0. Okay, now we can use the var keyword and we can just go for declaring it now. Based on the value, it will automatically convert into its original type, into its particular type again. So based on the value, only conversion happens. Because of that, you cannot declare it without initialization. There are actually 3 restrictions here, guys. Sorry, there are some few restrictions here. Restriction number 1. What's it? Declaration without assignment is not possible. Are you clear? Restriction number 2. Once declared, once assigned with a type value, cannot be changed again. What is that? Watch. Sorry. where I is equals to 100. I is which type, guys? Integer. Next, you're writing I is equals to 34.56. I is which type? I is an integer. I is which type? Invalid. Yeah, that only I said you. Again, you're telling a double. Read that. What did I say? Cannot be changed again. Are you clear? You already said integer. You modify only integer only, but not a double. But not a double. Okay? Sorry. First restriction. Declaration without initialization is not possible. Declaration without initialization is not possible. Second one, once assigned with a type value cannot be changed again. Cannot be changed. Okay, now cannot be changed to a new type again. Again, you will think I cannot change the value. I can change the value here. Within integer, I can change. I cannot change to new type again. Third restriction. What is third restriction here? We can use this only on here. The title of the concept is also same only. Read it. Implicitly typed variables, not fields. We can use it only on the variables. You cannot use it on the fields. Are you guys clear? Understood my point? So this is about the implicitly typed variables, what we have introduced in the C# 3.0 version. Okay? Next, guys. So there's some few drawbacks here. What are the drawbacks? Declaration time, initialization not possible. Second drawback, it cannot change the type. Third drawback, we can use it only on the variables but not on fields. We can use it only on the variables but not, I'm sorry guys, not on types written, not on, I'm sorry, wrongly typed. Not on fields. Because only variable declaration is possible but not field declaration. Global declaration is not allowed. What is allowed is only local. Local declaration allowed but not global declaration. To overcome these particular problems, guys, to overcome these three problems, what we have here, in C# 4.0, they came out with a new type called as dynamic type. Completely new data type. What is it? Dynamic. The name itself tells you it is dynamic. The name itself tells you it is dynamic. Hey, guys, why are you writing the notes here? Concentrate on the class here. Everything what I say you will be in the notes. You are focusing on writing the notes and you are not listening the important points. As it is, you will find in the notes. Why are you wasting the time? Just focus on the class. Understand point to point first carefully. You miss one point, you will be losing something. Focus. Okay? The notes will contain every point in it. Whatever I say will be in the notes. Clear? Yeah. What came now? Dynamic. Which version? 4.0. As the name tells you, this is dynamic, guys. What's it? Listen. Dynamic D is valid. Just like where only, guys. But dynamic D is valid. Where X is not valid, already see. First drawback. Not valid. But dynamic D, this is valid. Okay now? Next, watch. D is equals to 100. D is of type integer. Clear? D is equals to 34.56. D is of type double. D is equals to 2. D is of type double. D is equals to hello. Did you understand, guys, what is dynamic now? The name itself tells you dynamic. You can change it accordingly. Second drawback of that, where is that only? See, result now. First drawback. Without initialization, declaration is not possible. But see, possible. Second, once you specify a type cannot be modified. But see, I'm modifying in every line. I can modify this in every line. And third one, we can use this on in the second, third point. What is it here? We can use var only on fields, but dynamic can be used on fields and variables also. Var can be used only on variables, but not on fields, but dynamic can be used on variables and fields also. Array 3.0 var came here. 4.0, see, every new feature will come into existence to overcome the drawbacks in the old one now. Are you clear? So from now on, without using var, we will be using dynamic. No, sir, I want to use it in local scope specific. Then we go for var. I want to use it in a global scope dynamic. Then we go for dynamic. That depends upon your requirement. We don't have any standards. Use this or use this. Are you getting me? I'm not concluding you use this or use this. Because if I can conclude like this, are the designers fools to give you two options to you? They're not fools. That situation tells you. In this type of situations, we can use var. In this type of situations, we can use dynamic. That is what we will come to know going forward based on the experience only. That is not something which can be induced into your brain. Are you clear? It's not a vaccine to include into your body, guys. A subject is something what you understand the basic fundamentals. Based on the usage you learn. Okay, these are the characteristics of the var, these are the characteristics of the dynamic. Now what is your requirement? Based on that, then we choose whether to use var there or whether to use dynamic there. Is it clear, all of you? So these are the different things what we just have. One introduced in 3.0 and one introduced in 4.0. Okay, watch it. I'll show you an example with both the two things. So folder, guys, 10 now. Okay. Notepad var dynamic.cs using system class static void main. Look, all of you. I'm declaring var I is equals to 100. Dynamic D is equals to 200. Just for example, console dot write line. I'm not printing those values, just focus it. That's all. CSC. Read it. The contextual keyword var may only appear within a local variable declaration or in script code. Script code means a block of code. A block of code. But you cannot use it in a global. But you did not get the error for the dynamic. So then, var can be used only on variables, but dynamic can be used on variables fields also. Okay. So now let me bring this to inside. Let me bring this to inside. When you bring this to inside, is it valid? Yeah, it is valid. Now, because both are variables only, it's valid. The warning I got. What the warning? You did not use it anywhere, it is telling, that's all. You did not use it anywhere. Don't bother about that. You did not use it anywhere. That's what it is telling. Are you clear? And already explained you warnings will run the code. Warnings will compile. Warnings will run also. Yesterday or before yesterday, I shown you also practically. Yesterday only I think. Error will not compile the code, but warning will compile your code. So now the code is compiled, no issues with it. So don't bother about the warnings. Are you clear? Local declaration allowed now? Now. Read it. Implicitly typed variables must be initialized. Are you clear? The next are warnings here. Don't bother. I and D are never used in the code. That's what it is telling you. But it is not telling D is not initialized. It is telling only implicitly typed variables must be initialized. But it did not tell you dynamic must be initialized. Did you notice it? So declaration without initialization is possible, but not possible in this case. Okay now? Third one. Where I is equals to 100. Now tell me I is which type? Console dot write line. How to know? I dot. Array, we learned about this method yesterday, na? The get type will tell you the type of I now. You can clearly watch. But warning, don't bother about it, ignore it. Where dynamic. System.into32. Same way, here I'm just going to write dynamic D is equals to 100. And here what I'll print you? D dot get a type. D dot get type. Command C. That is also into 32. This is also into 32. Okay. The third difference also watch, guys. The third difference. Two differences I shown you already. Third difference. I equals to 34.56. Again, I dot get type. Same way. D is equals to 34.56. Watch. Read that. Cannot implicitly convert type double to int. You cannot convert here. You got the error with the eighth line. Eighth line, all of you. Eighth line. 1, 2, 3, 4, 5, 6, 7. Got it? You did not get any error here. Sorry, you did not get any error here. That is valid. Are you clear with the differences? What is showing between where and dynamic now? Where came in 3.0. Dynamic came in 4.0. Dynamic is, as the name tells you, it's really dynamic. You can do whatever you want with the dynamic, but whereas restrictions. Okay. So here I am writing where D is equals to valid now. Okay. Something I changed the name, that's all. Where D is equals to. Is it valid now? Now tell me which type. Louder. Decimal. It's a decimal. M na. M prefix is a decimal. Okay. Suppose I say where f is equals to. Now also decimal only. Decimal f. It's a float. It is a float. Next. Where ch is equals to a. What's that? It's a character. Next. Where b is equals to true. Next. Where s is equals to hello. Okay now? So like this, I'm just trying to do it. But when I come to dynamic, guys, all of you carefully observe. When I come to dynamic, I don't require to declare 5 variables like I declared in the case of the where. See here, first, I'm not assigning any value at all. Next, I'll say D is equals to 100. Next, I'll say D is equals to 34.56 F. Next, I'll say D is equals to A. Next, D is equals to true. And finally, D is equals to one variable only declared. That only I'm using up in my whole code. No need multiple. What you got it? What you got it? Both are same only. Check it out. Here, just I'll separate the outputs. I'll separate the outputs. Actually, you can use a right line method like this without passing any values. What it will do, it will print your line break. It'll print you a line break. Yeah, right line without any value will print you a line break. I separated the outputs to you, that's all. You got the same output in both the two cases, see? Understood? Huh? This is about var and dynamic. Var and dynamic. Var came in 3.0, dynamic came in 4.0. Yes, guys, I'll show you later. Where we use var, where we use dynamic. We'll check out all these things in the later classes. Next. Finally, one last thing about the data types. All this information what is giving is only about the data types only. One last thing about the data types. What's it, you know? We have a concept called as boxing and unboxing. We have a concept called boxing and unboxing. So what is boxing? Listen all of you. Int I is equals to 100. I is which type? Integer. Can I do this all of you? I already explained you. That's why I'm asking this question. Can I do this? Is this statement valid? Louder. Is that statement valid? Is valid, yeah. Already said your object is the parent of all the data types, can hold any type of value in it. That is why it is variable length type also. Clarified you already. Remember or not? Object is a parent of all the types and can store any type of value to it. You can assign any type of value to an object. So that object obj is equals to I is a valid statement. But I have a doubt. What is the doubt? Sir, int is a value type and object is a reference type. Int is a value type. Object is a reference type. You are assigning like this. So now the value 100, where is it going to sit? A stack or heap memory? Yeah. Heap memory. It sits on the heap memory. Actually, guys, we call this process as boxing. So what is boxing, you know? Boxing is a mechanism of converting a value type into a reference type. Boxing is a mechanism of converting a value type into a reference type. Boxing is a process of converting what? Value types into reference types. So we are going to convert the value types into reference types. To understand, I is integer, value type. What is a object, a reference type. So integer converted into object. So we call this as a boxing. Is everything clear, all of you? Yes or not? Then what is unboxing? Think, yeah, use your brains. What is that? Why are you telling fixed and variable? Yeah, I did not tell you na value type to reference type. I said we don't take fixed and variable length. What is reference? What is unboxing? Louder. Value type to reference type is boxing. Unboxing. Reference type to. Generally, when we say about boxing, we will reasonably understand what is unboxing. A reference type to value type is unboxing. Are you clear? So you can confidently answer in interviews what is boxing and what is unboxing. Boxing means converting a value type to reference type is boxing. Unboxing means converting a reference type to value type is unboxing. After this question, after you answer this question, this will be the next question for you. What do you know? String str is equals to 100. Value type or reference type? String is reference type now. Why are you telling value? Half an hour back we told the string and object of reference types. That is a reference type. Correct? So what's your answer? Reference type to value type is unboxing. Correct? The next question will be a string given to you. Convert this into integer. Convert this into integer and take your appointment letter immediately. You only said, converting reference type to value type is unboxing. Do it. Did you understand your mistake? A reference type can never be converted to value type. Yeah. Why? Reference types cannot be stored on stack. That's why we went to heap. And again, you're telling I'll push to stack. Where is it possible? Reference types can never be converted to value type. Remember that point. That's why When I say that, everyone will think reference type to value type is unboxing. That's why, to clarify that tomorrow you go to interviews and also answer the same thing only. That's why to get the particular point clearly, I explain you this one. Reference types can never be converted to value type. Not at all possible. How can you convert this into int or float or bool or double? You can't convert this into any type at all. Am I correct or not? Then what is unboxing, sir? What is unboxing is, if a value type is converted into reference type, that reference type can be reverted back into value type. Did you understand me? I'll clarify you. Watch. I have a value type. Converting this into reference type. What is this? I have a reference type. Convert this into value type. What is this? Invalid, yeah, not unboxing. That's what I said here. Invalid, you can't do that. You can't do no. Then what is this? Unboxing. I have a value type and I converted this into reference type, and reverting it back into value type is what we call as unboxing. Be clear first. Don't say reference type to value type is unboxing. If you say that, immediately it will give you a string and ask you to convert it. You cannot convert reference types to value types at all. What should be the answer? When there is a boxing involved and a value type is converted into reference type, converting that reference type back into value type is called as unboxing. Are you clearer or not? Converting this back into a value type is what we call as unboxing. A direct reference type can never be converted into value type. Are you clearer or not? Understood my point? So that's what boxing and unboxing is. So unboxing means first the value type should be converted to that reference type. Means simply, can I convert this obj back into integer? Yes or not? Yeah. What did you assign to obj? Integer only now. So converting it back to integer is possible now. So look. Int j is equals to obj. This is called unboxing. Are you clear? But a small point to explain you guys. Okay, just a minute. What is unboxing? Unboxing means converting a reference type which is created from a value type back into value type. Are you clear? But unboxing requires an explicit conversion. What is that again? See, anything can be assigned to object. I already clarified you yesterday or day before yesterday. Anything can be assigned to object. Object is the parent, anything can be assigned. But did I say object can be assigned to anything? Tell me, yaar. Did I say object can be assigned to anything? Be active, yeah. Behaving like you are 20s only, no? You are behaving like 50s. Please be active first. What did I say? Value types can be converted to, sorry, anything can be assigned to object, I said. But I did never say object can be assigned to anything. Correct, huh? Now also same point. Object cannot be directly assigned to int. Conversion required. How to convert? Convert dot to int 32. What is that? Convert is a class, guys. Just like console, convert is a class. Int 32 is a static method in the class. It will take an object, convert into integer. Now, simple English here, convert to. If you directly use the simple English, convert to into 32. What should I convert? OBJ. So once you convert into 32, it should be captured in a integer variable. This is what we call as explicit conversion. Are you clear? We don't forget. String str is equals to hello. Explicit, implicit, whatever you do and you break your head, that cannot be converted to integer at all. Am I clear what I'm telling you? Sir, can I do explicit conversion? Array, you can do here. Here, explicit conversion, implicit conversion, nothing will work. That can never be converted to integer at all. Is my point clear? Why? Because reference type to value type conversion is invalid. Is it clear, all of you? What can I do? Then only that reference type to value type is a valid statement. Did you understand what is boxing and unboxing? So tomorrow I will clearly show you where do we use this boxing and unboxing in our applications. Are you clearer, guys? Tomorrow I will clearly show you where do we use boxing and unboxing in your applications. So guys, all of you, I hope everyone has notes now. Read carefully each and everything what I explained you. All the things what I explained you. Today, starting from value types, reference types next, nullable value types next, implicitly typed variables next, dynamic type, differences between var and dynamic, and afterwards the example code what I showed you, finally boxing. And guys, everything what I explained you till now is completely about data types only. Okay, how do we convert obj back into that? Only I done it. Int j is equals to convert dot 2 into the ditto. Hamid, this is the process. Int j is equals to convert dot 2 into the ditto. What is convert? Convert is a class. 2 into 32 is a static method in the class. Not only 2 into 32, guys, you have so many methods. 2 double, 2 float, 2 char, 2 string. Like this, you have so many methods that are available for you under that one. The converting into the different types. Right. Today it is integer, you are converting to integer. With boolean, you will convert to boolean only. Na? With a double, you will convert into double only. For everything, there is a method available under the convert class. Convert is a class and all these are static methods. Everything clear? Yes or not? Okay. So read them thoroughly, guys. Tomorrow, I will show you how or where exactly boxing and unboxing will be helpful in your application code. Okay, now? Let's stop here. We'll meet tomorrow. And code which is in notes when compiled is coming full of errors. A coming errors means you're written something wrong. Show me the code, I'll tell you what is the error. Without showing the code, I'm getting errors means I can't tell you. Show the code, where you made the mistake, I'll tell you. Nickel. Show me, yeah. Show me the code. You think you're copied and pasted. What you done without saying, how can I say? Show the code first. Until you assign a value that doesn't have any type. Okay, hi guys. Nikhil, send the code in the WhatsApp group. We'll check it out. Okay.
Recording stopped.